I'm very happy to have this chance to introduce the AliSQL. The talk's name is AliSQL Breakthrough for the Future. The keyword is breakthrough, and I will detail what we did on AliSQL in the past years. This is the agenda. The talk includes 3 topics. First, let me tell a little of history about AliSQL. Last year, my teammate Dengcheng He introduced AliSQL to the world for the first time. AliSQL does a lot of work based on MySQL community version and support most of applications in Alibaba. In the last year, AliSQL has a new start. We had a new key value interface, XKV, and the class solution, S-Cluster. So first is history, okay? AliSQL is a MySQL branch originated from Alibaba Group. It was born 6 years ago. As the roadmap shows, we created AliSQL based on MySQL 5.1 version, and at the very beginning, we tried to fix bugs and optimize the performance by ourselves. With our e-commerce business boosted, we did a lot of work to optimize the performance for our scenario, just like the hot SKU. Millions of customers will always rush to buy a small number of goods. In database system, it means that a large number of sessions try to modify single record. We had implemented 2 versions of optimizations to deal with the hot row contention problem. And last year, we updated the baseline to 5.7 and integrated the RocksDB engine. In Percona Live 2016, we introduced all these list features covering both server layer and storage engine. In the last version of AliSQL, the throughput of a single key update reached 100,000 per second. Hot SKU is no longer a problem for us. We implemented row cache, grow update algorithm, and a new type InnoDB row lock. The details can be found in the last year's slides. As many people know, there is a single-day shopping festival in Alibaba. Like Black Friday, billions of people will take part in the panic buying because of the special price only for that day. This year's Alibaba Singles Day became the world's biggest shopping festival, and our system should deal with a huge number of transactions. In order to support such a large number of concurrent requests, we need a powerful OLTP database system with extremely high performance, strong data consistency, and low cost. So we introduced XKV and S-Cluster to our business. So the second topic is XKV. What is XKV? XKV is an extension of InnoDB Memcached Plugin. This key value interface is widely used in our business. There are several reasons about why we use the KV feature. First, there are so many simple queries according to primary key or unique key in our business. Second, comparing to the cache in traditional architecture, key value interface embedded in database system will not have a problem about data consistency. Third, the SQL parsing and query optimization is too expensive. By using key value interface, we can achieve both high performance and low cost. So, what is the difference between the InnoDB Memcached Plugin and XKV? The reason is the current InnoDB Memcached Plugin cannot satisfy our needs. The XKV supports more data types and index types. And we designed a new protocol for XKV. We also optimize the performance for GET operation, and it is easier operation and maintenance. First is the data types we supported. In the original InnoDB Memcached Plugin just supports char, varchar, and blob in value fields, but it is not enough. Our customers require a cheap way to access data in database. In the key value interface can support any type of data, it will be perfect. SKV support float, double, datetime, and other types. And most of these types is serialized by default embedded MySQL function. Besides, we backport the multi-get feature from MySQL version 8, and we support non-unique index and return multiple rows of value. SKV also support a composite index and a prefix search. To support these data types and index type, a new protocol is necessary. Original protocol has its limitations. Customers are always worrying about how to distinguish string noun and noun values, and how to ensure that the selected delimiters will never occur in field value. We redesigned the new protocol. Every data field, both in key and value, has a meta-info follow the raw data. Meta-info records the data length and the total record number. For example, noun value has a length of 0, and the string noun has a length of 4. To support the composite index, we extended the get command. It now contains an array of fields. Next, for convenience. In our production environment, DDL cannot be ignored. InnoDB Memcached Plugin only loads configuration when plugin is installed or the instance is started. So, if DBAs want to modify configuration to add new schema after DDL, he should stop all KV requests and then reinstall the plugin. However, in online environment, this operation is unacceptable. SKV support online schema change. We use a hook to connect the container table and in-memory configuration. It can be modified dynamically. The change of the configuration will not block any request from a client. We also do a lot of work to improve the performance. In our experiments, we found some bottlenecks to lead to the low performance, like the efficiency of serialization and the frequent allocation of the transactions and container info verifying. The experiment is simulated our production environment. As the chart shows, the pillow in blue is performance before optimization, and the pillow in red is our last test result. The single get performance increased by nearly 1.5 times, and the multi-get from 4 tables performance increased by nearly three times. Okay, next is the X cluster. SKV support extreme performance and low cost, but when instance is crashed or network is isolated, the data consistency is hard to guarantee. So let me introduce the AliSQL cluster solution, X cluster. It has a background. In the article, extension consistency measuring and understanding consistency at Facebook. The other said that the large web service faces a trade-off between stronger forms of consistency and high performance properties. However, in Alibaba, the data consistency and the performance is both very, very important due to our trade and payment business and the user experience requirements. The basic idea: we should use cluster solution to deal with the data consistency problem. The master-slave replication cannot guarantee data consistency. We can choose the popular consensus protocol like Paxos or Raft to ensure the data consistency. And then we must take advantage of AliSQL because In the past 6 years, we did a lot of work on it, and we must inherit those features and optimization we did. And about performance, batching, pipelining, synchronization is always the key tag to boost performance. The basic idea is to improving the utilization of CPU and reduce I/O. Regardless of the network latency, our X cluster should provide robust and reliable service. It is a huge challenge to maintain the throughput in a high latency network, but we believe that the latency will never affect the system throughput. This is an example of a 3 nodes X cluster, including 1 leader node and 2 follower nodes. As we can see that instances are connected by consensus layer in the orange block. As we can see that a cluster use consensus log to communicate with each other and sync the data. The consensus layer we call X Paxos. It is a powerful consensus module. It provides strong consistency, meanwhile manage the whole cluster. And I will introduce the X Paxos library later. Okay, X Paxos is an independent library for high availability cluster. It uses a leader-based multi-Paxos algorithm. The library is implemented by an async framework, so it is very efficient. Its log is pluggable. Everyone can develop the consensus log by implementing some simple interface. Paxos also provides the ability to change the membership online, include change the leadership, add or drop the member, and adjust the member's attribute. And second, it has ability called election weights. A node with higher weights are almost likely to be selected as a leader. Paxos supports customized role. One node can be configured to any types, include leader, follower, learner, and trip node. Learner is just like a read-only node and never requests a vote. A trip node just saves the consensus log, but no data. So it is a costless choice. Based on X Paxos, we made an X-class system, include database cluster and online backup system, the data subscriber, and other data transmission service. We provided an X Paxos SDK for our system to watch the consensus log and the change of the data. Okay, come back to X cluster. We use binary log format to implement the consensus log. There are several reasons. First, binary log can record all the change in database, both DDL and DML. Besides, bin log is not bound with any storage engine. In AliSQL, it can serve all transactional engines like InnoDB and RocksDB. Instead of traditional binary log and relay log, we just use one consensus log in one instance. I/O is reduced. Transaction is permitted to commit only if majority of instances in the cluster synchronize the transaction log. If less than half instances alive, the cluster won't lose any data. Okay, in order to support geo-distributed feature and provide the high throughput, we did a lot to optimize the performance. And as I mentioned before, batching and pipelining is a key tag. There is an example of the optimization on X Paxos. We use batching and disorder packet transmission to optimize the log replication performance, batching can reduce the times of sending and receiving, and disorder can increase the parallelism. In this graph, we compare the order transmission and the in-order transmission. Disorder transmission can replicate more packages in the same time. This chart shows the performance result of the data transmission. The x-axis is the package size, and the y-axis is the total number of packages sent. The red line is in the low network latency, about 0.1 millisecond. And the green line stands for high latency network, and with nearly 30 milliseconds. And as you can see, the throughput is almost the same in either low or high latency network. And there is another problem in the server layer. Thread pool limits the number of concurrent worker threads to eliminate the data race. But however, most of threads are waiting for committing, especially in the high latency network. Because ACK cannot return immediately, utilization of the CPU is very, very low. We must find some way to improve it. So we implement a synchronized commit feature. We use a batch separate backend threads to do the commit work. The front thread will give the transaction to the backend thread when committing, and do not need to wait the consensus log synchronization. The number of concurrent connections will grow fast, and the CPU can allot more resource to deal with the user requests. The backend threads just need to commit the storage engine and send the request back to the user client. The total number of backend threads can be configured according to the current system load dynamically. Okay, let's see the benchmark result. This chart shows the max throughput between the single node AliSQL and the 3-node X cluster. The pillow in blue stands for single node AliSQL, and the pillow in red stands for X cluster. X cluster's throughput decay within 10%, and the response time only increased less than 1.5 milliseconds. So I think the performance is very good for the cluster solution. And we also compare the performance versus MySQL group replication 5.7 and 0.17. We can see that in low latency network, the result is in low latency network. X cluster's max throughput is more than 2 times, and the response time is just half. In high latency network, with 30 milliseconds, the X cluster's max throughput is 5 times of the group replication, and the response time is just 1/3. So, XKV and X cluster is a new start of AliSQL. XKV, we support more data types, and we designed a new protocol. We had a better performance and easy to maintenance. As cluster, the cluster solution of AliSQL, it has strong consistency of data, and it supports geo-distributed with high performance. Okay, that's all about my topic. This is my contact info. I'm now a database kernel developer from Alibaba Group. If you have any questions about this slide or our project, please feel free to contact me. By the way, we are high. Welcome to join us. Thank you.
So the interface is just
The client access.
data from the InnoDB engine.
Okay.
Okay, thank you. It's local and query the data in the InnoDB data engine. So besides this or before this, we think about implement or add a cache layer on the database, but that will introduce the inconsistency problem. So we use this InnoDB Memcached Plugin, but it's not as good as we think. So we implement it to XKV. So, okay.
It's actually share the same buffer pool.
Yeah.
When you use the KV interface to access the data, it's actually accessed the InnoDB buffer pool. So it's actually the same.
Yeah.
Yes.
Yeah. You may say the performance test it achieves 640,000，应该是65万是这样说的吧？ It's you can you can see the performance test. Yeah. This is the performance of
640,000.
Yeah. It's the performance of the XKV interface. But if you use SQL interface or SQL through PK or SQL through UK, you must not get this performance. So this is why we use in the DBX Memcached plugin, or why we implement it to XKV. Okay, thank you.
Yes, as mentioned, the SQL parsing and the query optimization is too expensive. Yeah.
Okay. I have a question. How much of this is open source?
Yeah, as you may know, we open source AliSQL on Git, but some of our problems, some of our features, just like we said today, is not incorporated in it yet, because we implement all this last year. We want to use this on our production and make it much maturity, so we can incorporate it to the open source. But some of the problems or bugs, like we fixed in the InnoDB Memcached plugin, we feedback it to MySQL bug reporter. Okay. Okay.
Any other questions?
Okay.
Okay.
Somewhere like a specification of the protocol that you made, like the wire formats.
So you may ask us whether we have any document regarding the protocol we have made. So actually, we will just provide such kind of specification after we have that open sourced in GitHub. Because actually we have did a lot of customization according to our business in the moment for this specific version. So we would like to make it can be used generally for all you guys. After that, we will just open source it on GitHub, and we will ship that with the document as well.
Yes, we already use the protobuf to serialization this message in the protocol buffer. Yeah.
Okay. Thank you.
Thank you, everyone. Thank you.